Dear students, let us learn more about the chapter units and measurement. You all know about the constant pi. The value of pi that we write is 22 by 7, which is also equal to 3.142. I can even write 3.14 or even 3.1, and maybe for approximation I can just write a 3. So when I write 3.14 to 3.14, 3.13, which is more precise? Definitely the value which is 3.14 is more precise, and that value, if I use in any calculation, will give you a better value, or we can even say that a value with less error or least error. Now in this particular number, when I write 3.142, the digit which has more significance is this. In any measurement, the first digit has always more significant. It's more significant in terms of the measurement, and the digit which is least significant is the last digit, right? So the first digit is called most significant digit, which we write it as MSD, or you can even write MSF also, most significant figure. The last digit is called LSD, least significant digit, or is also called as a least significant figure. And then from the most till the least, if you count how many digits are there, 1, 2, 3, 4, and that 4 is called as number of significant digits in a given measurement. So therefore, that's what the topic is all about the significant figure. So how to define or how to understand what exactly significant figures are? The number of digits required to express a physical quantity correctly are called significant figure. So what is significant figure? The number of digits required to express a physical quantity correctly, more precisely, are called significant figures. Okay. Now look at this example here only. What are the number of digits here? There are 4. 1, 2, 3, 4. How many significant digits are there? Most, least, and total, it is 3. How many significant digits are here? 1 and then 2. How many significant digits are here? Only 1. Look at this. Only 1 significant digit, only 2 significant, only 3, only 4. Greater the number of significant digits, more is the precision, or we can say that this value is more correct. It's given physical quantity correctly. So this we can say that this is a more correct value, more precise value compared to this. We don't say it's wrong, no. They are correct. The values are all correct, right? Which is more correct out of this? This is more correct. That means if I write one more digit, something like 3.1421, how many significant digits are there? Total 5. So now compared to this is a more correct value. So hope you understood what is the meaning of significant figure. It is the number of digits required, correct, in a physical quantity or in a measurement to express it more correctly is called as significant figures. Okay. The number of digits required to express a physical quantity correctly are called significant figure. Now, how to identify most significant digit and how to identify least significant digit? There are certain rules are there that depends on whether the number is a decimal or a non-decimal number. So that's what I'm going to explain, and the question will be asked in the exam, like identify the number of significant digits in a given measurement. Okay. So first let's learn the rules, and then we'll come back to the example for it. Clear? Okay. So the rules to find the significant figure. So in any given number, there are certain rules are there to identify most and then to identify the least. Okay, right. Check this table. This table will give you the complete rule. So first we are going to focus on non-decimal, number without decimal. This is the first case. Okay, which is the other one? The decimal. These are the only two possibilities that you come across. We don't have the third category. Non-decimal, decimal. I will give example also. So first, what is the rule? If it is a non-decimal, the most significant digit, MSD, is the first digit is the most significant digit. Are you clear? Okay. Then, which is the least significant digit? The least significant digit is, see that, it is the last digit which has to be non-zero. Are you clear with that? It has to be non-zero digit only, not zero digit. It has to be numbers other than 0, like 1, 2, 3, 4 till 9. Okay, right. Let me give an example. Non-decimal. I am going to write a number 32,000 here. Okay, then I will write another number. It's 43210. I will write one more. See, these are all non-decimal. There is no decimal involved in it. Okay, right. After that, I am going to write 10,000. Then I will write 273. Then I will write 8308. Okay, so these are all non-decimal. Okay, right. So let's identify the type of numerical is a non-decimal. Clear? Non-decimal. Which is the most significant digit? The first digit. So these are all most significant digit. Okay, the first digit is the most significant digit. Are you clear? Okay, and now which is the least significant digit? It has to be last non-zero. This is a 0, so this cannot be the least. This is 0, this cannot be the least. This is 0, this cannot be the least. So this is the last non-zero digit. Are you following, students? Okay, check this next number. So this is the most, this is the least. Okay, here it has to be non-zero. This is 0. So this is non-zero. Clear? Okay, here 0, 0, 0, 0. This is the most, right? So there is no least significant digit in 10,000. Okay. Is this the last non-zero digit? Yes. Is this the last non-zero digit? Yes. So in a given digit, you identify which is the most, which is the least. Okay. And once you do that, count the number of digits from most till the least, not in between, including both. So how many digits are there? Most and the least. 1, 2. So this is the number of significant digits. There are 2 here. 1, 2, 3, 4. Okay, next only 1. Then 1, 2, 3. What are these actually? These are number of significant digits. Okay. Then 1, 2, 3, 4. So this is how you can identify in a non-decimal number. Non-decimal. Clear? Okay. Let's go for, I believe you all have understood this. Let's go for the decimal now. Okay. It has to be a number with a decimal only. There has to be a decimal point. Okay. Right. So which is the most significant digit? The first non-zero digit. First non-zero is most, and which is the least significant digit? The last digit, any digit. Okay, the last. There is no rule here. They have given last digit is the least significant digit. Okay, let me give an example now. So it has to be a decimal. So I can write like this: 12.530. Okay. Then 12.5412. Then I will write 0.015610, 0.020010. Okay, right. So these are all you get to see. There is a decimal. Here there is a decimal. Here there is a decimal. Here there is a decimal. Okay, what is the rule? It has to be the first non-zero digit. First non-zero. First non-zero. First non-zero. It has to be here. So first non-zero, it has to be here. So what I have marked? I have marked most significant digit. Clear? The first non-zero digit. Okay. Then what is the least significant digit? Last digit. Any digit. There is no rule. Last. It has to be the last digit in the given measurement is the least significant. Last. No problem. Even if it is 0, no problem. Are you clear with that? That is the rule. So that is how you have to identify. So 0 here. Last digit. Last. The last and the last. That's the least significant digit. Are you clear? Now let's count the number of significant digit here in this and in all the 4 numbers. Okay, right. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You know, with the non-decimal, the last digit has to be non-zero digit. Last non-zero digit. But here, it has to be last digit, irrespective whether it's a 0 or non-zero, no problem. It has to be the last digit only. I hope you understood the identifying most, the least, and the total number of significant digit. Okay, right. So let's take some more example from the table that's given. Okay, I've already given the example, and I'm going to write the answer in the table itself. Okay, right. So first you have to identify whether it's a non-decimal or a decimal. Okay, right. So let's go with all the non-decimal first. So this is non-decimal, this is non-decimal, this is non-decimal, this is a decimal. So first I'm going to complete these three. Okay, what is the rule? In a non-decimal, the first digit is the most significant digit. Most is this, correct? This is the most. This is the most. This is the most. Okay? It's a 2, 3, 1. Okay, I will write here 2, 3, 1. 2, 3, 1. That's the most. Which is the least? The rule. What the rule says? Tell me. It is the last non-zero digit. Last non-zero. The last non-zero. Here there is no significant. Clear? Because there is only one digit, right? Okay. So, which is the least significant digit? 4, 5 and no. 4, 5 and nothing. Because this number cannot be most as well as the least. Okay, right. So, that has to be most. Fine. So, this will verify later because it's with the decimal. Now, how do you count the number of significant digit? From the most till the least, okay, including both. So, 1, 2, 3, 4, 5. So, 5 is the number of significant digit. Am I right? Okay, the next one, 1, 2, 3 is the number of significant digit. Okay, what next? There is only one. Yes. So, we have completed all the non-decimal. Let's complete the decimal. What is the rule? In decimal, it is the first non-zero. First non-zero. First non-zero is this. And then which is the least? The least is the last digit, any last digit, which is 3 here. So, one is 8, the other is 3, correct? Yes, now count the number of digits, okay, that is the significant digit. So, 1, 2, 3, 4 and then 5, here it is. So, this is how you can find the most, least and the number of significant digit, okay, right. So, let's see more numbers, more example, so that I can make things clear. So, what are the questions are possible here? Just to identify the number of significant digits in a given set of number. That's it. Okay, right. So, one more set of examples. Okay, check this. So, this is with the decimal, with the decimal, with the decimal, with the decimal. So, all the numbers are with the decimal only. So, which is the most significant digits? First non-zero. First non-zero. Correct? Okay, what is the least significant digit? The last digit, any last digit, any last. So, this is the last. This is the last here and this is the last. Understood? Right. So, first most 5, 1, 1, 1. So, here it is 5, 1, 1, 1. Okay, I am just writing the digit. Okay, after that 0, 0, 5, 0. 0, 0, 5, 0. Okay, how about if there is a power, scientific notation? No problem, just leave it, ignore it. Okay, you don't have to bother about the notation which is given, concentrate only on the number that's given. Clear? Okay, right. Now, let's count the number of significant digits. How many are there? So, 1, 2, 3, 4, 5, 6. 6. Okay, right. So, here 1, 2, 3, 4. 4. Here 1, 2, 3, 4, 5. And here 1, 2, 3, 4, 5. 5. Understood this? So, this is how you can find the number of significant digits. Okay. So, one more interesting point is, suppose if I am going to give a number, okay, like this 0.0, 2, 3, 4, 5. Okay. I will write this in terms of the scientific notation. Okay, scientific notation. How? Shift this decimal from here 1 and then 2. Okay, write this as a 2.345 into 10 to the power minus 2. Okay, I'm just reading the number. I've written it in terms of scientific notation. Okay. Now let's calculate the number of significant digit before rearranging and then after rearranging. Okay, before, it's a number with a decimal, so most is a 2, least is a 5. So 1, 2, 3, 4 is the number of significant digit. Now check this. Most is a 2, least is a 5, total 4 only. So you can see, even after rearranging the number, the number of significant digit will remain the same. Okay. So this is the point. This is a point which you have to remember, that writing scientific notation will not change the number of significant digit. Okay. Right. Okay, so let's attempt one question, objective question. In objective question, there will be 4 options given, and you have to select the correct one. Okay, right. So the number of significant figures in the numbers, there are 3 numbers are given. First one is 23.023, after that 0.0003, and then we have 2.1 into 10 to the power minus 3. So these are the 3 numbers given. You are asked to find the number of significant digits. So which choice is correct, whether it's A or B or C or D. So first, with the decimal, most and the least. Most is the first one and the least is the last digit. Total 5. Okay. So but that you'll find in, so this cannot be the answer because here it's given 4. So but 5 you will find in 3 options, B, C and D. Let's try the next one. So again, it's a number with the decimal. Most is the first non-zero. There is no other. So therefore, that has to be 1. Number of significant digits 1. So 5 and 1. So now the option cannot be D because it's given 5, 5. So 5 and 1 is given in option B and C, 5, 1. So we have to verify the next. Okay. So most and the least. So total 2. So 5, 1, 2 is the answer. So choice is option B. Okay. Understood? So very simple, easy question. Okay. So let's check one more question. Question is, which of the following has the highest number of significant figures? So they have given 4 numbers now, A, B, C, D. Out of this, which has the highest number of significant figures? Okay. So let's calculate here itself. So in option A, so we have, this is the most, right? Most and the least. Correct. Most is 3, least is 2 because it's with the decimal. So what is the rule when with the decimal? With the decimal, it has to be first non-zero digit is the most significant digit. So total 1, 2, 3, 4. Okay. Then in option B, it's again most is 1, the least is 0 because that is the last digit. So total 4 again. Option C, this is number without the decimal. Check that, without the decimal. What is the rule? First digit and the least is the last non-zero digit, non-zero. So it has to be this. So total 2, correct? 1, 2. And now in the option D, so we have again with the decimal, first is 1 and that is the most is 1 and the least is 0. So total how many? 5 are there. So 5. And the question is, the following, which of the following has the highest number of significant figures? So the option is choice D is the answer. Okay. So this kind of objective questions can be framed from the competitive exam point of view, and for that you should know the theory behind it. Understood? Once you know the theory, then attempting this kind of question is very easy. Okay? Yes. So there is one more question, which has appeared in the board exam for 1 mark question. In 2013, they have asked in the district level. So what is the question? Mention the number of significant figures in 0.006 meters square. Mention the number of significant figures. A very simple number is given, 0.006. Okay. So what is the answer for this? There is only one digit and it is with a decimal. The most is a 6 and there is no least significant digit. So therefore the answer to that is 1. So 1 is the answer. Okay. So in the exam, board exam, it's enough if you just write this number, you will get 1 mark. So hope you have understood the concept called significant figures, how to identify most significant figure, least significant figure, and number of significant figures or significant digit in a given number, and for which you have to remember the rules which I have explained it. Okay.